Let's talk about section 5.5. In here, just like what happened in section 4.5, we are solving radicals, just like section 4.5 was solving rationals. So here we've got a radical. And when we solve radicals, the most important thing for you is what I have hidden under here. You must get the radical by itself first. Whatever the radical is, it has to be by itself. Okay. Then the other thing that you have to do, just like what happened with rationals, is that we must check our answers. Two things that are an absolute must: get the radical by itself and check your answers. So if we look at this, our radical is by itself. This is ready to go to be solved. Okay, let's look at some other ones real quick and figure out if the radical is by itself or not. So here's another one. Is my radical by itself? Absolutely. There is nothing else over here by the radical. It is equal to just a number. So this is good to go, like what we had a second ago. This radical is by itself. What about this one? If you said that the radical is not by itself, you are correct. This square root of x is not by itself because I have this plus 4. So this is one of those that we need to fix. And again, to fix it, just like what we did with absolute values, whenever an absolute value was not by itself, all the way back at the beginning of the year in A1, all we have to do, how do we get rid of a plus 4? Subtract 4. So we'll subtract 4 from both sides, and we get the square root of x equal to, well, 7 minus 4 is 3. Now, this radical is by itself. It's ready to be solved. Okay? Again, is this radical by itself? And this x minus 3 is under the radical. It is protected by that radical. It's like a whole jail or a house right here. So this is all one radical. So you can't get rid of the minus 3. It's under the radical. So is this radical by itself? Hopefully you said no, and that means we got to move this plus 6. How do we get rid of a plus 6? Well, just like the plus 4, we subtract it. Minus 6 minus 6. So we have the square root of x minus 3 equal to 10 minus 6 is 4. Okay? So then last but not least, well, I think, actually I might have, yeah, I do have 2 of them left. Nope, 3 of them. All right, so going back. Is this radical by itself? Nope. Again, just like our last one, this radical is not by itself. So how do I get rid of a plus 5? Subtract 5. Subtract 5. So square root of x minus 4 equals, what's 3 minus 5? That is a negative 2. Okay? So I got 2 more. So now this one is a little bit different, but it's just like the absolute value stuff that we dealt with. Is this radical by itself? Absolutely. So is this one. So that's a good thing. We just can't have radicals both on the same side. We got to have them separated, just like in absolute values. Okay? So both of these radicals are by themselves. So this problem is ready to go. Well, what do you think about this problem? Is this radical? Well, is this radical by itself? Yes. Is this one by itself? No. So this problem, it's going to take a little bit more to it to get radicals by themselves, and we're going to see that soon enough. So we're going to save this problem for last. Okay? So let's go back and let's talk about all these ones now that we have where the radical is by itself. So once the radical is by itself, all we got to do is get rid of that radical. So how do I get rid of a square root? Well, in order to get rid of a square root, we're going to raise it to a power. What power will get rid of a square root? And that will be a power of 2. Or in other words, squaring gets rid of a square root. These are the yin and the yangs to each other, and you've seen those before. So if we square a square root, that's going to take care of the root and take care of the square, leaving you with x. Equal to, well, what's 9 squared? And that is 81. So this could be the answer, but we have to check it. Okay? So the check, we're going to take the 81 and plug it in. So is the square root of 81 9? That's the question. And it is 9 equal to 9. So the check is good. That means this answer is A-OK. Cool? All right. Go ahead, try this one on your own. Pause the video. Okay. So we already knew that this was by itself. How do I get rid of a cube root? Well, what power do I raise it to? And if you said the cube power, you are absolutely right, because cubing gets rid of a cube root. So they cancel, leaving you with x. And then if you just go to your calculator and you cube the negative 4, you should get a negative 64. Okay? You're just using your calculator to double check that information. Okay? So now you just got to do a check. And so you go in and we plug it in. So here's the check. So is the cube root of negative 64 negative 4? That's the question. Well, the cube root of negative 64 is a negative 4 equal to a negative 4. So it checks out. So this negative 64 is indeed the answer. Okay? So on this one, again, we've isolated the radical. So we had to subtract 4 to both sides. We isolated it. So how do I get rid of a square root? Just like what we did before, square it. So x equals, because the square root and the square cancel out, 3 squared, which is 9. Again, we got to check it. So if we plug in, is the square root of 9 plus 4 equal to 7? Okay. Well, what's the square root of 9? That's 3 plus 4. Is that 7? And absolutely. So this answer is valid. Okay? Go ahead, pause the video, finish this one up. Okay? So again, hopefully you're looking at a square root. How do I get rid of a square root? We square it. So the square root and the square take care of each other, and that leaves you with x minus 3. 4 squared is 16. So, in this one, we got to take an extra step here because now we got to continue to get x by itself. How do I get x by itself? Add 3, x is equal to 19. And again, in the end, we need to check our answer. So we plug that 19 back in. So 19 minus 3 plus 6, is that 10? So 19 minus 3 gives you 16 plus 6 equal to 10. Square root of 16 is 4 plus 6 equal to 10. Is 4 plus 6 10? Absolutely. So this answer is A-OK. Pause the video. Give this one a shot. Okay. So if we square both sides to get rid of that square root, so the square root and the square take care of each other. That gives you x minus 4 equals, what's negative 2 squared? That is a positive 4, no matter what your calculator tells you. How do I get rid of a positive, or how do I get rid of a minus 4? We're going to add 4. So x is equal to 8. But again, we got to check it. So if we plug in, we've got 8 minus 4 plus 5 equal to 3. So 8 minus 4 gives you the square root of 4 plus 5 equal to 3. Square root of 4 is 2 plus 5 equal to 3. Does this check out? No, it doesn't. It tells us that we have 7 equal to 3. So this answer right here, you have to completely throw out because it does not work. It does not check out. Well, since we threw out this answer and that was the only answer, the solution to this is a no solution. There are no answers that are going to work. But in IMathAS, that will be the D and E that you put into the blank. But it really is a no solution. Okay? So that is the answer to this problem because, again, it doesn't check out. This makes no sense. 7 equal to 3. All right, now this one. We've already talked about it. So let's work this one together. Actually, the last two we're going to work together because these are different. So we already know that these radicals are by itself. How do I get rid of a square root? We're going to square both sides, which is nice because the squaring of both sides actually takes care of the radicals, which leaves us with 2x plus 9 equal to x plus 7. Now it's just a small equation to solve. So we need to get all of our x's on one side. So I'm going to subtract the 1x that's right there and subtract it over to the other side because there is an imaginary 1 in front of that x. So 2x minus 1x gives us x plus 9 equal to 7. Subtract 9. I don't know why I'm writing 2 because I'm really thinking about the answer actually. Subtract 9. Subtract 9. X equals, that gives us a negative 2. So is this the answer? Well, we've got to check it. So we plug it in. Square root of 2 times 2. Times negative 2. Plus 9. Does that equal the square root of negative 2 plus 7? Well, 2 times negative 2, that's a negative 4 plus 9. And this side still is the same, negative 2 plus 7. Well, what is negative 4 plus 9? That gives us the square root of 5. What's negative 2 plus 7? That gives us the square root of 5. So is the square root of 5 equal to the square root of 5? You betcha. So this answer checks out. That answer is A-OK because both sides are the same. Now this one. This is the one that's going to take you the most amount of work. This is the one that gives people the most trouble. Okay, so what you actually have to do in this one is you need to isolate the radical twice. Okay, so right now we already have this first radical isolated. So we're going to take care of that right now. So how do I get rid of this radical? Well, we're going to take and we're going to square both sides. Okay, so if I square this side, the radical and the square take care of each other, and I'm left with x minus 2. But on the other side, this means I have 2 of these parentheses. You can't distribute the 2 through. It doesn't work like that because of the addition and subtraction that might be going on. Do not distribute through. What you need to do is you need to FOIL this out. This is a side that needs to be FOILed. And after we FOIL it, we're going to have to isolate the radical x minus 7. So like I said, we've isolated the first time, and then this is going to be the second radical that we have to isolate after we FOIL and combine like terms and things. So we've got x minus 2. So we FOIL. 1 times 1 is 1. 1 times the square root of x minus 7 gives us 1 square roots of x minus 7. Because again, that's a number, that's a radical. They don't really multiply each other. They just go together. Multiplying the inner. Again, that's another positive 1 square roots of x minus 7. And last but not least, what happens when I take 2 radicals that are the same and multiply them together? The information underneath pops out. So the square root of x minus 7 times the square root of x minus 7 is just x minus 7. Now let's combine like terms. So x minus 2 equals, is anybody getting together with the 1? You bet. The negative 7. So that gives us negative 6. These two in the middle are going to get together because they actually have the same radical, square root of 7, square root of 7. And as we learned back in 5.3, you can put like radicals together. So that gives us plus 2, because 1 plus 1 is 2, square roots of x minus 7. And then last but not least, no one is getting together with the x. So what we now need to do is we need to isolate this radical. Just like what I said before, you actually have to do it twice. This first one was already isolated for us, which was great. And now, after all that foiling and combining, we need to get this square root of x minus 7 isolated. So that means I got to get rid of this negative 6. I got to get rid of this positive x. I got to get rid of this multiplication of 2. All right. So let's isolate this guy right here. In order to do that, how do I get rid of a negative 6? We're going to add 6. How do I get rid of a positive x? We're going to subtract x. So what's going to happen over here? Well, the x's actually cancel each other out. And negative 2 plus 6 is 4, equal to 2 square roots of x minus 7. So now, this is multiplication, as I said a moment ago. How do we get rid of multiplication? You're going to divide. So 4 divided by 2 is 2, equal to the square root of x minus 7. Now we have that radical by itself. So now we can get rid of that last radical. How do I get rid of a square root? Square it. So 2 squared is 4, equal to, the squaring takes care of the square root, x minus 7. So all we have to do now is get the x by itself by adding 7, adding 7. So 7 plus 4 is 11. Now again, we have to check this. Okay? So we'll do the checking right here. So we're going to plug 11 in for those x's in the original equation. So we've got square root of 11 minus 2 equal to 1 plus square root of 11 minus 7. So 11 minus 2, that's the square root of 9, equal to 1 plus 11 minus 7. That gives us the square root of 4. What's the square root of 9? That's 3. 1 plus the square root of 4 is 2. So does this check out? Absolutely, because you end up with 3 equal to 3. So this x equals 11 is a valid answer. And that's how you solve radicals. The biggest thing is you have to get the radical by itself, and then you get rid of the radical or the root by taking it to the power of whatever the root is. If it's a square root, we squared it. If it's a cube root, we cubed it. If it's a fourth root, we would have taken it to the fourth power. Last in this, I've got one more. I thought I was done. So the last thing in this, as you saw, there's going to be a word problem, which is not hard. We'll talk about this in just a second. Go ahead and pause your video and give this one a shot. Okay, so is this radical by itself? No. So how do I get rid of a plus 2? Subtract 2. So these two aren't going to get together because they're not like terms. So we have the square root of x plus 4 equal to x minus 2. My radical is by itself. How do I get rid of a square root? We square it. And so this is kind of like what we did last time, although we do not have to worry about a radical on this side. So over here, the square root takes care of the square. So that gives you x plus 4 equal to, now there are two of these parentheses, x minus 2, and x minus 2. Do not distribute the 2 through. It doesn't work like that. You need to FOIL this. So x plus 4 equals x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is a positive 4. Combining like terms on this side, the two middle pieces get together. So that gives us x squared minus 4x plus 4. So if you're thinking factoring on this one, you are absolutely correct. We need to set this part equal to 0. So let's move this x to the other side by subtracting x. Let's move this plus 4 to the other side by subtracting 4. So minus x minus 4. So what we have then is 0 equal to x squared minus 5x, and the 4's end up canceling each other out. So now all you have to do is factor this. Well, this is easy factoring because all it is a GCF. I'm going to go ahead and move this information onto the left side because I like working with it on the left side. So that's x, because you're going to pull an x out of both of these. And that'll leave you with x minus 5 equal to 0. Well, since it's factored, we use our 0 product rule. Set each one of these factors equal to 0. So that gets set equal to 0. And the parenthesis gets set equal to 0. So x is equal to a positive 5 here because we'll add 5 to both sides. So again, now we need to check two answers. So we need to check the 0 answer, and then we're going to check the positive 5 answer. So I'm going to grab my equation up here. So square root of x plus 4 plus 2, does that equal x? So square root of 0 plus 4 plus 2, does that equal x, which is 0? So 0 plus 4 gives us 4 plus 2 equal to 0. Well, the square root of 4 is 2. Does 2 plus 2 equal 0? No, that doesn't make any sense. 4 equal to 0. So this answer of x equal to 0, we have to check out. It did not check. So let's deal with the next one. So square root of 5 plus 4 plus 2, does that equal 5? Well, the square root of 5 plus 4, that gives us the square root of 9 plus 2 equal to 5. Square root of 9 is 3 plus 2. Does that equal 5? You bet. This one checks out because it's 5 equal to 5. So this is the only answer that works. X equal to 5. All right. So like I said, the last thing is there's a word problem. This word problem is not hard. All they want you to do is plug in and solve. Okay? So they've given us this formula here. Okay? V stands for volume. Pi is 3.146, as they told you right down here. That's our pi. H is what stands for height, and R is the radius. So all they want us to do is plug into that. So first things first, it says the height of a cylinder is 11 centimeters. So that's H. So kind of plugging in what I know. Down here, this is 3.1416 because that's pi. My H that's down here is 11. It says right here the radius is 4. So that's 4. It says use the given formula to find the volume. So the piece that we don't know is V. So we plugged in. All we got to do now is solve. How do I get rid of a square root? Square both sides. So the square and the square root take care of each other, which leaves us with v all over 3.1416 times 11 equal to what's 4 squared? That is 16. Okay? So how do I get rid of division here? Well, to get rid of division, you multiply. So both sides are going to get multiplied by what's in the denominator here. So we're going to multiply by 3.1416 times 11. So 3.1416 times 11. So all we need to do is go to our calculator and multiply all three of these numbers together. And that's what will tell us what V is, because those pieces cancel each other out. And if we look up here at the directions, it says, it doesn't tell us where to round. So let me explain how we're going to round on this one. So we're going to take 16 times 3.1416 times 11. So there's our answer. So the first thing I'm going to, when I input this, I'm going to round it to the nearest whole number. So the 4 says, hey 9, stay the way you are. So I'm going to have my answer be 5,579 centimeters first. And I'm going to try that answer. Hopefully it likes it. If it doesn't, then just like what we've done before when we were dealing with the Pythagorean theorem, I'm going to round to the nearest tenth. So the 8 says, hey 4, go up. So next I'll put in 5,579.5 centimeters, because the 8 said, hey 4, go up. If that didn't work, then I round to the nearest hundredth. One of those three answers should work, whether it's whole number, tenth, or hundredth. So the hundredth says, hey, the 1 says, hey 8, stay the way you are. So the last answer I would try, 5,579.48 centimeters. Hopefully it tells you where to round, but if not, those are the answers I'm going to try. And this is a real world problem, so you don't have to check this. Okay, this is A-okay, this is good to go. And that is 5.5.